Hello and welcome to Beginners Python and Machine Learning. My name's Tim Cummings. We're a meetup group. Every Tuesday we present a session on using Python, and on the first Tuesday of every month we try to present a session that's specifically targeted at absolute beginners who've never seen Python before. So tonight's session was supposed to be an in-person session at the State Library, but Annie couldn't make it because she's been hit by COVID and she's not feeling too well, so I've decided to take it over, and I'm presenting her script tonight. Now you can, one of the benefits of these sessions is that you can chat with us live, so you can do that through Slack. So we're in the Learning to Code session, and also in the YouTube chat. So let's see, where's YouTube chat? Here we go. Yep. So you can chat here, and I'll follow that. So that should be just to the right of the video that you're currently watching. Just hang on. Okay, sorry about that. I just had another computer that was actually playing back the video, so I was getting a bit of an echo here. Alright, so let's, in the below the video and below the meetup session, if you've registered the meetup session, I've put a link here to the code that Annie's provided. So you can, we'll grab that in a sec. So we'll just have a look at what learning objectives today. So the first one is installing Python and IDE. So you can put Python on your computer in several ways, and I like to install the one from python.org. So you can go to downloads here and download Python for your operating system and install it. Now that just gives you the bare bones Python, gives you an IDE called idle that you probably would never use, and so I would I'd use a different IDE. I like to use the one from JetBrains, so JetBrains.com, called PyCharm Community Edition, which is free. A lot of people like to use Anaconda, especially for those in the data science world, because that comes with Python, but it also throws in a lot of third-party libraries. And those third-party libraries can be, just means that you don't then have to install them later. But it's not hard to install them later, just knowing where they come from. I just recommend using the distribution of Python that other people around you are using, so that when you talk to them, you're coming from the same page. But what we're going to use tonight, we're going to use Google Colab, which is another way of using Python, but doing it online. That's a very good way of running Python. In fact, some people in data science, that's all they ever need. It's a very powerful system. It's running Python 3.7 at the moment. So that's what we're going to run tonight, and it's really good for learning because it's very interactive. So you can type in some code, get immediate results, and that loop of submitting a line of code and then getting a straight result makes it really improves the learning process. All right, so the two things we need to do: we need to download the code from Annie. So I've got a link here. So if we click on that, that will open up the code, and just as a text file. And the other thing we need to do is to create a new notebook. Now I'm going to create a notebook, and you can share that, and that's probably the easiest thing to do. So let's see if I can do that. I'll go to Google Colab. If you want to go to Google Colab yourself, it's just colab.research.google.com. Anyone with a Google account can then set up a notebook. I'll set up a notebook here. It starts off untitled, so I'm going to call it Meetup 147. Alright, and it's going to have a bunch of cells down here which you can put either code or text in, and you can create new code or text cells, as you can see. Alright, so the first thing I'll share this link to this notebook so that you can view anything that I'm doing, but you won't be able to make changes to it. So let's see, anyone with the link is a viewer. Alright, so I'll copy that link and I'll send that to you in Slack. And I'll also send it in the YouTube chat. So let me know if it doesn't come through. But yeah, definitely ask questions as we're going along, so that you get some feedback if you're having any problems. Alright, so let's move that to a new window. So I'll have the code here on the left, and this is our Google Colab here on the right. So in Python, anything that starts with a hash is a comment, and the very first line is a special coded comment that just says this file's in UTF-8 format. This is actually not even a Python format. That's come from a different editor, but we're using Python 3 these days, so you don't even have to put this UTF-8 in there. Any Python file, any Python script file is assumed to be UTF-8. Now you can create, you can start off your Python script, and this one file is what's called a Python script. You can put a string of instructions in here about what the script is all about, and just enclose it in these double quotes. But they don't. It just creates what's called a documentation string, a doc string. So people wanting to find out what your code does at a later stage can read what's up there, and they can see what it's all about. And there's even programmatic ways of getting this information. So if I put this into a code cell and run it, it doesn't do anything except create a string. And you can see it's starting to connect. So the very first time you run something in Google Colab, it has to create an area to run. Gives you a bit of RAM, a bit of disk space, and in this case it's created our documents string. Now the other thing I could have done here is I could have created that as a text and type that in there. And this is using markdown formatting, so I can just change the formatting a little bit here so that it looks a bit neater. I'll make these bullet points. And then I press Shift Enter, and it saves that text there, and now there are links that you can actually click on. So this is where Google Colab is slightly different to your standard Python. It lets you put these markdown cells in as well, and that's a feature of a thing called Jupyter Notebooks, which is a particular breed of Python called IPython that Google Colab uses, and there's some other providers of Jupyter Notebooks as well. All right, now if you've got this shared link to Meetup 147, and you want to start making your own changes to it and see how it goes, you can go down to the file menu and say save a copy in Drive, and that'll save a copy of this notebook. It'll create a copy and save it in a form that you can then edit it. So it'll get a new name. It's now called Copy of Meetup 147, and you can make changes here. And you see it's in a new tab, so you can always go back to the old tab. You can refresh this page, and you'll get all the changes that I'm making tonight through this session. All right. Now the first thing that Annie's brought up here is showing us how strings work. So I'm going to paste this into the cell, and you see I've got a play button here, or I could press Control Enter, or I could press Shift Enter. So Control Enter will run the cell and leave me in the cell. Shift Enter will run the cell and take me to the next cell. So let's run that cell. And what that's done is it's created this bit of text here. My first string uses single quotes, and it's stored it in a variable. So by putting these single quotes around the string of text, it tells Python that this is the string of text, and then this stuff outside the quotes is the Python command. So I've got a variable called s1, and by saying s1 equals and this string of text, then I'm able to save this text into the variable. Now if I want to see what's in that variable, I can use the print command, the print function, to print out what's in s1, and I run that, and there it goes. It prints it out for me. Prints out my first string uses single quotes. So I could do that, just that function again, and it would do that with remembering what's in that memory location. That's the point of memory, is to keep remembering what things that are there, and you can change them later to different contents, and so it prints it out again. Now there's a couple of ways of doing there's a few ways of doing strings in Python. You can also do them using double quotes. And so when you use double quotes, you can use whichever one you feel like it. Although if, for example, your string contained a single quote as one of the characters in your text, then it's really useful to be able to use double quotes around it. And similarly, if your string contained a double quote, then it's really useful to be able to use single quotes to be the delimiters at the front and end of it. Alright, now there's also you can use triple single quotes or triple double quotes. So here's an example using triple single quotes. And notice how Google Colab has done some color coding for us. It's showing us a string in red here, showing a variable and other code in black, and the print function it's showing in this brown color, and the comments it's showing in green. So comments just don't do anything. You can ignore them. Oh, well, in fact, they're useful for you because you can read them, but the computer ignores them. So triple single quotes are useful because they can go over several lines, and you can see here there's a line feed between over and several, and when it gets printed, we go from over to several. There's a new line in there. Now at the end of lines, and he's put in here a \n. Now \n is a special character in strings. It means a new line. So it's done a new line, and then there's a new line actually after it. So we're getting two new lines after lines, and go down to if, and then two new lines between and end. So here's another way of using the print function. Up until now, I've just used the print function with printing values of variables. We can actually put the string straight into the print function. So inside these parentheses is the parameters to the function, and what we're putting in there is a string, hello world. So if we run that, it will print hello world. Yep. Now other functions in Python, there's a type function which tells you the type of a variable. So we've got a variable we've created earlier called S1. We've got to find out what type that is. So we can pass type into our print function, and it will tell us that the type of S1 is a string, and it prints that out for us. Okay, so we're going to do some more. Looks like we're going to run methods on strings. So string, if you is an object that's got methods, and you can run a method on an object by using this dot notation. So you do the variable name, then a dot, and then what function that's built into that object that it can do. So a string knows how to capitalize something. So what capitalize does is it takes the string, which, as you can see up here, my first string uses single quotes, had no capital letters in it, and it makes the very first letter a capital. You can also, there's a function there for converting every character to uppercase. And that's the upper function. There's one to convert everything to lowercase. So normally when it's a function based on an object like this that you call using this dot notation, they're called methods, although they are functions as well. And then when then other ones are just plain functions. So once again, there's our that one's created S4. And we're going to do operations on the strings. Okay, that looks like fun. So it's taken S3, it's converted it all to lowercase, it's stored the result of that into a variable called S4, and then we've done S4 times 2, and that's using the asterisk operator, which is in when you're doing mathematical operations, will multiply a value by 2, but it also works on strings, and what it does for a string is it takes whatever string you had and does it twice. So the string is my second string uses double quotes, and now we see it twice. My second string uses double quotes because we've put times 2 in there. It's all in lowercase, even though up here S3 was in uppercase because we ran the lower method on it before we saved it in S4. So the other operator you can use on strings is the plus operator. So you can put plus between these variables, and you can even put in a literal string of one space in there, so that makes it look better. So it's S1 plus S3, this is S1, this is S3, and there's a space in between them when it prints. Okay, so have a little bit more of a look at variables. We've got a new variable name here called x, and it's got the string. A variable is used to store data, and we're going to print that, and it prints a variable is used to store data. Now we've got a very long string here. We haven't even saved it to a variable, and he's used that as a way of putting a message in her code, but then deciding to throw it away as she doesn't need it. and she's describing what she's got here. So x is a variable that I can call again later. X is something that's subject to changes. A string is a type of data. Other data types are floating point numbers, which is float. So string is abbreviated to str. Floating point numbers are float, and integers are int. And there you'll find lots of other data types as you work with Python. Okay, variable names, they must start with a letter or an underscore. And I'd recommend not using underscores until you're a bit more advanced. They're case sensitive. These are immutable data types, which means they cannot be changed in place. You can assign new values to them, but they will occupy a different place in memory. And the implications of that are probably a little bit advanced for a first session, but just to know that you can't change one of these in place in memory. A variable containing an immutable data type can replace its value with a new value. Yep, that's what it said. So you can name your variable anything except the following keywords. So there's a list of keywords that you can't use. And I would have thought there'd be more than that. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. Oh no, that's about right. 30, 35, 33. I think there's a couple more. Like async is one that you shouldn't use either. But you're unlikely to need a variable called async. So yeah, make sure you don't call your variables any of these. You'll immediately get an error if you do try. So keywords are part of the Python language, which is why they're called keywords. So you'll use these. Any other words like print, for example, that's just a function name, so you can override that if you want and assign your own value of print. But these ones are keywords, they're fixed, and you can't change them or even use them. Alright, move on to data type numbers. And we're going to start with integers. So integers are numbers without anything after the decimal point. They can be positive or negative whole numbers, including 0. And you can see if you look up what the type of A is, it's an int or integer. And that was -5. So you can see how we haven't put quotes around the -5. And so that means it's not a string. So it then gets interpreted as an integer in this case because it's got no decimal point in there. However, if we did put a decimal point in, like if we said pi equals 3.147, then Python would work out that this is a floating point number because it's got a fractional part to the number. And you can do mathematical operations on integers and floats. For instance, plus, minus, times, division. This one's called floor division. And, well, that's an interesting one. That's a bitwise operator. But you'd probably, if you were doing power, you would probably use star star. It's more common. Okay, so let's look at some examples of these. So if we have 10 divided by 3, we get 3.3333 all the way up to 35. So you can see there's a bit of a floating point error happening at the end there. But it's such a small number to be insignificant. Unless you're actually relying on it, then that can cause you problems. But there's workarounds for that, which we can describe later. Okay, so we're taking an integer with another integer and using the division sign, and we get a floating point number. Now, alternatively, we could have used floor division, which takes an integer divided by another integer, whatever the result is, 3.333, it then goes downwards to the floor to the next integer, and down, and that's in this case just 3 by itself, and you see there's no decimal point there, so that is a integer. Now if I started off with floating point numbers here, so if I did 10 point floor division 3, it would go, oh, we're working with floating point numbers, let's stay with floating point numbers. So even though it's done the floor division, it will leave it as a floating point number and display it as 3.0. But the point of what we're doing here is integer, floor division, integer. And so this floor division has a complementary operator, the modulo operator. Which is the percent sign, and that gives you the remainder. So 10 divided by 3 equals 3, remainder 1. Alright. Now we've got libraries are a group of functions. Yeah, so there's some standard libraries that come with Python. So for example, math is a library. So we can, I'll get rid of the comments here, we can import that library, and once we've imported it, it means we can use it, and we can get help on it. So help's a very useful command. You can use it in Python console, you can use it here in Google Colab, which is IPython. And it tells us all the things that are in the math library there. So you can see it's got functions, it's got even some constants. So math.pi, math.tau, which is 2pi, math.e, even math.infinity, and math.not a number. Okay. Alright, another data type. So this is some of the really useful data types that come just standard with Python. Is lists, and if I could copy that properly. So to create a list, you use these square brackets, and then you put in the items in the list, and you separate them by commas. Now we've got a few different items here. We've got a string, an integer, another string, an integer, another string, and a floating point number. So what are we going to do with this? I'm going to put these in the same cells. So we've created this animals list, and then we're going to find out what the length of the list is. And the length is 6, and as you can see there are 6 elements in that list. So the question is, what is the element with index number 2? And these are the indices here, 0, 1, 2, 3, 4, 5. So the one with index 2 is cat. And when we print it out, we can refer to an element in a list by its index or its position using square brackets by the list name, and then we put in this index, and it's a 0-based index in Python. Everything's 0-based. So it starts with 0 for the first one, 1, 2, 3. And that's really, so that's come from the C days. When the C language was developed, the first one had in an array had an index of 0, and so to be consistent with that and a lot of other programming languages, Python is also uses 0 indexes. Okay, we're using our slice here. So animal ij returns a new list, and I'm going to call it animals ij, containing the objects all between I and j. Alright, well in that case we better give I and j some values. So let's say I equals 2 and j equals 4. Okay, so animals ij is going to give us, starting from index 2, going all the way up to, but not including j, which is 4. So once again, this is, you'll find this fairly consistently through Python, that when they do a range like this, the second value is an up to, but not including that value. So we've got 2, which is cat, 3, which is 5. We don't include 4, which is hens, or 5, which is 12.7. So we just get cat 5. And one of the advantages of doing it that way is that if I want to predict ahead of time how many values I'm going to get, I can always just go 4 minus 2 is 2, and so I'm going to get 2 values, and sure enough, that's what I got. Okay. Now with lists, you can change them in place. One of the ways you can change them is by assigning a value to a particular index, and we can say we want index 1 to now be the value bears. So if we print animals after assigning bears to index 1, you can see it's now dog, it's not 3 anymore, it's dog bears, cat 5, hens 12.7. Alright, now a data type which is very similar to lists is tuples, or tuples. I say tuples, other people say tuples. And so you can create one just by putting a list of, well, a sequence of values here, all separated by commas, or you could put parentheses around these and it would do the same thing. I would normally put parentheses around, but anyway, in this first example we're doing it without parentheses, and that works. Now tuples have all the properties of lists except that you can't change them in place. So they're immutable data type, and there's some advantages in having immutable data types. Okay. As you can see, you can refer to them by index, still using square brackets. Oh, okay. Yeah. I was wondering how we got a list coming out, and the reason we've got a list is because we've assigned a list as the fourth element here. Animals is a list. As you can see, I'm hovering over it, and so when I refer to this index 3 of our tuple, it's actually the list, the whole list of animals. So you can see we've got different things. We've got a string, we've got an integer, string, a list, and another string. Alright, so what are we doing here? We've created a rainbow. This time we've put parentheses around it. And so you can define them without using the brackets or using round brackets. Lists use square brackets, as we saw before. Dictionaries use curly brackets. Dictionaries and sets use curly brackets. Tuples are like lists, but tuples are immutable, as I mentioned. Tuples have fewer functions, so you don't get pop, drop, insert, append, and you can't assign by an index value. They work on lists, but they won't work on a tuple. And benefits retain its value regardless of functions applied. So if you pass it as an argument to a function, you can know that that function is not going to change the value of any of the elements of your tuple, because it can't. All right. Meanwhile, a list, animals, we can do things like append, and we're going to append a rabbit. And so if we append rabbit to animals, we now get the same animals list as we had before, plus wrap it at the end. We tried to do that to a tuple. Let's see what we get. We get a type error. Alright, one thing I might just mention, if you want to create a single element tuple, if you try, let's say, if we put parentheses around it like this, Python's going to simplify that and go, oh, you just put parentheses around it, we're just grouping it, there's only one there, we don't even need to do that, so it'll just remove the parentheses. And so T1 will just be the string 1, and the type of T1 is going to be a string. So if you do want to create a tuple that's only one element long, you need to put a comma in there, but don't put anything after the comma. And that way, when we print T1, we can see we've got the tuple there, and it's got the comma at the end as well, just to make it clear that it's a tuple. And if we look at the type of it, it says it's now T1 is of type tuple. Okay, let's have a look at another data type. We'll look at dictionaries, and this is one of the really powerful features of Python. And what it is a mapping structure, so we get lots of keys and values pairs, key value pairs, so we can look up any of the values by its key. So for example, if we had a dictionary of cities, and we have a country on the left and then a colon and then a city name on the right, then we can use these keys on the left to look up what the capital city of that country is. Now if I've created this data structure for cities, normally your variable names you'd start with lowercase, so let's do that. Uppercase you use for classes, but lowercase for variable names, and that's just a convention, it's not necessary, but if you keep to the convention, then it makes it easier for other people to read your code. And then we just said type of cities is dict, which means it's short for dictionary. You see here I haven't even put print around to print that type, and this is because I'm using IPython. If I could just put an expression and it will display the results of that expression here without me having to use print. But that only works in IPython, like Jupyter Notebooks and other, in Google Colab and other vendors of Jupyter Notebooks. So I tend not to get used to it. I prefer to use the print command whenever I am doing it. Alright, so back to dictionaries. Let's have a look. Now we can assign values using the square brackets notation, to like just what we did with lists. We could use a number-based index. Here we can use a key-based index. So I can set the city for Australia to be Brisbane rather than Canberra, and I could add a new one, Antarctica being none, the word none, so it's got quotes around it as a string, and then when I print it out I get all 4 countries and their cities. Alright, So we've seen they associate keys with values, while lists and tuples are just a sequence containing values. I won't say set because that will get you mixed up with another data type called set, which means that every value has to be unique. But in lists and tuples, they don't have to be unique. A list keeps order, dict and set do not. Okay, a list keeps order. Set does not. So dict doesn't keep the order. That used to be true, but since Python 3.6, it will use it. It does keep the order. So I think we'll just put dict over here. We haven't used sets at all. A set is an unordered collection of items. Are we going to use sets? Yes, the next one's sets. Okay. Every element is unique, no duplicates, and must be immutable, cannot be changed. However, the set itself is mutable. A list and dict may have duplicates and are mutable. All right, now I saw before you could find how to find help, and that works in Python console. In Google Colab, you can actually just type a question mark and what you want to get help on, and it will show up here on the right hand side. It tells you a bit about dictionaries. You can even do double question mark, and that gives you something slightly different. What's that going to give us? In this case, it's going to give us the same thing. All right. So let's have a look at sets. So we're going to create a set using curly braces. So it's like a dictionary, only we're using curly braces, but there's no colons and values. You can see the type has come back as set, and they all have to be unique. So if we tried to add the same thing again to one of those, it won't appear twice in the sequence. Okay, eggplants is now in the sequence. And we can find help on set if we want to. Okay, Booleans. So Boolean, named after a guy called Boole, who was a logician, I think, and he liked knowing whether things were true or false. So there's two values, true and false, in Python, and that are and they're the only two values of type Boolean. Now you can get anytime you use particular operators like these conditional operators, less than, greater than or equal, less than or equal, or equals, you'll get a result as a Boolean. So for example, we can say what's 10 less than or equal to 9? And the result to that is false. And you see it's false with a capital F, which so it's good to be aware of that capital, because that's where Python's a little bit different to other languages which use lowercase f. You can also call functions that have a Boolean result, such as is s2 a numeric. So s2 is a string, is numeric, is the value of the string numeric, and the answer to that is false. I haven't used numeric much, so let's try a string with the value 3 in it. And see what that comes back with. That comes back with true. Alright, so you can store Booleans in variables just like any other data type. Let's run that. So my fact is looked at this expression here. Does 5 equal the length of fruits? Let's hover over this and see fruits has got 5 items in it. So yes, 5 does equal the length of fruits. So it goes, evaluates that to a true and stores the result in my fact. And then you can print my fact and you get the answer true. And you can find the type of my fact, and it will be a Boolean, which in Python is abbreviated to bool. Okay, if statements. Alright, so we've done a few data types. Now we'll start looking at how to do some coding. I haven't received any questions yet. No questions come through. Alright, if statements use Boolean logic. If statements will only execute if the condition outputs to true. Don't forget to end each conditional statement with a colon. So a colon, that's the double dot there, and you can see when you put a colon at the end of a statement, it tells Python that you're about to start a code block. And a code block in Python is identified by indentation. So it's indented 4 spaces. That's the standard in Python, the convention. You could do different numbers of spaces, you just have to be consistent. And you can even use tabs, but most people will use 4 spaces for each indentation. Let's close this help. Colon, indent the code below the conditional statement. The else if statement allows you to check multiple expressions for true and execute another block of code. So here's an if with an else. So here's one code block, and then the end of the code block in Python is indicated by the removal of the indentation. So that's why this else here is not indented. And then it starts, it's got a colon there, so it's starting a new code block which is indented. Print 2 cups is enough. Alright, so we've got a variable here, coffee, saying how much coffee we've had. If that value is less than 1, we need more caffeine. And if it's not greater than 1, then it'll say 2 cups is enough. Now I think this logic is slightly wrong, because if I put coffee equals 1 here, it's going to say 2 cups is enough even though I've only had 1. So what I need to do to fix this code is I need to put an equals sign here. So the expression is if coffee is less than or equal to 1, I still need more caffeine. And it's great, need more caffeine. And then once I get to 2, it'll tell me 2 cups is enough. So you can see why this IPython is so great for learning your code, because you can just concentrate on a few lines of code and run it over and over again. You don't have to worry about a whole development environment. You can just be looking at these couple of lines of code and see exactly what they're doing, and change a few values and rerun it, and see what the results are. So it's a great learning tool, and even a very powerful tool for people who don't want to actually write programs. Okay, for loops. Structure of a for loop. Okay, let's have a look at that. So the for loop in Python is very eloquent. it's just you have the word for to say I'm starting a for loop, then you have a variable name here, and then you have the word in, and then you have a sequence that it's going to iterate over. So in this case, the sequence is going to be the list of all our planets. And so every time we go through the loop, our variable, is going to have a different value, the next value of the planets. So you can see the first time it goes through, it says, it prints Earth, then Jupiter, then Mercury, then Uranus, and then Pluto, and then Venus. But it doesn't get to Mars, and the reason it doesn't get to Mars, we put this break statement in here. So this is something, you'll use it in for loops. Maybe about 5% of your for loops will have a break statement in them. And so you generally have a conditional in front of your break statement. So it's checking for some condition and only break in those conditions. But apart from that, it would go right through to the end of all the elements in the sequence. All right, what have we got here? For loops are for iterating over through iterables. So in this case, a list is an iterable. Iterables include lists, strings, dictionaries. For loops will go through each item in an iterable and execute the statement and move on to the next item until there are no more. Hence, for loops are perfect for processing repetitive programming tasks. With the break statement, we can stop the loop if the statement is true. In the above example, I have specified a loop to break if the item is equivalent to the value of Venus. You can do many fantastic things with for loops as long as you understand the logic behind it. You can use a for loop inside another for loop, nested for loops. Here is another example. So this time we're going to use a dictionary. So we've got keys and values inside curly braces. And for v in results.values, if v is greater than 90, well done, A plus for you. All right, so let's run this and see what we get. So the first one was 44. It said close but no cigar. The second one was 97. Well done for you. Well done, A plus for you. 82 came up with you passed the exam, and haha, you failed. All right. Now, we just results as a dictionary, but we're only looking at the values. Now, we could have looked at the keys and the values. So to do that, we look at them as item pairs. And in the for loop here, we can put a key and a value. And then we'll print the name of the person first. And we want to keep it on the same line. So rather than the end being a new line, we'll make the end just be a space. And so now I've got Annie, close but no cigar. Tim, well done, A plus for you. Arun, you passed the exam. And John, haha, you failed. Alright, well that's demonstrated a fun use of for loops, and also how to use an if statement with else if, and else. While loops. So while loops execute a piece of code while a condition is true, and the loop continues until the while statement evaluates to false. So it's pretty important when you're using while loops to make sure that there's something in your loop that's going to change the value in your testing condition so that eventually it'll return false. because otherwise you'll have what's called an infinite loop. It'll just keep going round and round and round forever, and your code will never finish. So in this case, we're starting off with count equals 10, and we're just checking that it's greater than 0. 10 is greater than 0, so the first time it will actually go through the loop. It'll print the value, and then we'll subtract 1 from count. So this notation here means take the value of count and replace it with count minus 1. And then this line here, print liftoff, that's not in the code block, so that's not indented. So it's all the lines that are indented that will get repeated until count is no longer greater than 0, which means it's 0. So you'll see here 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, liftoff. So 0 doesn't print, but instead we get print liftoff. Okay. So now we're going to teach while else. So I guess that's good to teach because it's something you've probably never seen before in other languages. It's not a common thing to use, but what it means is that you didn't encounter a break statement during the logic of your code. So in this particular example, there isn't a break statement, so the else will always get run. And let's see, if we run is less than 5, less than 5, 5 is not less than 5. So else was always going to get run. So in this case, it would have been the same as if we just done this. We'll get exactly the same result. However, let's see, we've got an example here using break. So let's say if count modulo 3 equals 0, then we'll break. Let's say 7. And then we can put an else in there to say print no numbers divisible by 7. So 0, 1, 2, 3, 4, 5 is less than 5. 5 is not less than 5. No number is divisible by 7. So that's saying it didn't reach the break. And now if we change this number here to, well, we'll change this one here to 3. And so we'll break if we hit 1 by 3, and really that's not gonna look good. Well, we'll run it anyway. So 0 is less than 5, but we don't say no numbers divisible by, and that should say 3, because we did hit a number divisible by 3, and then we've got 3 is not less than 5, which doesn't make sense, but that's just our logic is wrong. But that's just showing how you use a break and an else. Don't really have to worry about that too much. You'll hardly ever use breaks and elses. I mean, breaks you'll use occasionally, elses pretty rare. And I think we're on our last example here. Continue. Yep, so continue. Break will take you out of the loop. Continue means go back and continue on the loop, but don't do anything after that's in this code block after the continue until you've iterated. The pass statement is a null operation. Nothing happens when it executes. Okay, we haven't got any examples of paths here, so probably won't go into that. So what we've got here, we've got a while loop, while number in range 10. So range is a good way of what are we doing here? Number's always going to be in range 10. Oh, I guess number's changing. Yep, so that's all right. If number equals 5, so it's number is 5, doesn't get printed out because we've done a continue. That means it skipped everything else in the code block after it. And then it checks is number in the range 10, and it keeps checking that while number's going up, and eventually when number is 10, 10 is not in range 10, and you can see here it's doing the increment before it's doing the printing. So this test is happening in number before number gets incremented, and this display is happening after number got incremented. So you just have to be aware of that. Okay, so that's it for this week. I hope you've enjoyed it. I hope you've learned something from it. I didn't get any questions on either YouTube chat or Slack. But if you've got questions in the future, feel free to ask them in the Slack, and someone might monitor that. Just refer back to this meetup, and they'll be able to help you. Next week, we're going to be a bit more advanced session. It's going to be we're going to be looking at what we can do with a Microsoft account, and so using a REST API. So it'd be things like sending emails using your Microsoft account, but doing it from a Python program, or the particular instance we're looking at will be uploading a file to your OneDrive. So it'll be a file that we'll create programmatically. So we'll create a PDF file in our Python code and then push that up to a OneDrive so that any of your devices that use OneDrive will be able to see it. Okay, that's good. Peter says he loves REST APIs, and they are very powerful and very useful and very common. So they're a good thing to learn, and it'll be a fun exercise to go through. Microsoft have given some pretty good examples to help us understand what's going on. All right. And he says, thanks, that's great. I hope you enjoyed it, and I'll talk to you next week.